and also lay the ground about why generative AI has been successful, right? So generative AI is a new way of, uh, as the name suggests, generating text, images, and you would possibly see audio and video also coming into the picture very slowly. And it's based on patterns that it has seen. Means it's a very generic definition, right? And there's a reason why it's getting popular. It's getting popular because people are getting scared at the technology, right? The technology is so scary. You look at things like this, where you have a good average to good developer, for instance, he's immediately productive by a scale of 30% already for a boilerplate code. And the reason it's scary is because of a small thing that used to exist earlier, which was called Stack Overflow. If you asked every developer a year earlier, what was the first thing that guy would do? He would possibly search for a code on Stack Exchange, right? Copy paste some code, start coding immediately. And then you would figure out, okay, maybe in a day or two, this guy is getting successful. Now the traffic rates for Stack Overflow have dropped as close as 30% after the release of ChatGPT and Copilot. That's remarkable for a utility or a website that was considered to be means almost a part of the development lifestyle or development tool chain, for instance, right? And then there are very interesting things which are coming up. Meaning, we'll talk about generative AI a little bit more, but I wanted to lay out the broad landscape of things that are doing, that are happening, right? And we'll show you some interesting applications along the way, which are very real in nature also. And Professor Sobhan has worked on one such application that he's going to demonstrate later. So people talk about very interesting words, right? Like hallucination, right? So uh, in the previous session, I think Himanshu mentioned that blockchain has a very interesting way of using words. I think we take it a stretch beyond blockchain when it comes to AI. So generative AI, hallucination. And hallucination is the concept of basically the concept of generation itself. What is new that is being generated here? But alongside hallucination, what if we were able to mix the real as well, so as to give you much more context behind what is being presented? So things like ChatGPT with something like a real answering engine called Wolfram would give you more than what a ChatGPT by itself provides. Right? I'm going to breeze through this very quickly. Or things like product visualization, meaning if you just roll back 5 years and you look at some of the projects which were coming out there in the startup market, you would probably see some startup companies which were trying to visualize how a customer's dress would look like, how an ad agency would create a print, for instance. What would be the final product looking like? What would be a text for a marketing look like, for instance, right? Visualization pieces that a lot of companies would invest a lot of energy. Now, almost all those projects are available using something like a DALI, for instance. Right? You put in the description of what you intend to show, and you instantly get an image. Right? And that's a very powerful way of thinking. If you want to create a movie poster using Shah Rukh Khan, what would be the first thing that comes to your mind? I mean, a year before this, you would possibly call upon Shah Rukh Khan to do the actual ad. Now, most of you would possibly not even consider that as a first option. And it's a powerful change. And it's a scary change, right? I'm using the word scary very intentionally, but and then it scared bonkers out of large organizations, right? Something ChatGPT, for instance, has had that effect, where all the large companies started taking up notice to a technology which Google themselves had created, right? So there was a classic paper called "Attention is What You Need," which introduced the world of transformers. And that is the same technology that has blossomed so well. It's being used as a fundamental building block for generative AI tech. The market size is also growing. So if we were to project what the market would look like, it's possibly looking to be close to 110 billion by 2030. And we are already at possibly 7 to 8 billion right now. I'll pass it on to Sobhan to cover a few cases in the world of finance and banking. And then we are going to deep dive into greater detail, reveal some of the technologies which usually go behind the scenes in the world of generative AI. Sobhan.
Hi, good afternoon. So, what I'm going to talk right now is, first I will show some applications of generative AI in banking and finance, which are low-hanging but heavy revenue-yielding applications. And after that, you might ask how this entire magic is happening. And we'll see some algorithms. We will not dig down the math behind it, but we'll talk about what are those algorithms actually creating this revolution in the society. And we'll see some use cases which we implemented some movie industry. So let us look at it. So in banking and finance, there is a lot of use cases you can find which can revenue yielding. One can be simple applications like account inquiries. Why you need people there? Why can't you have machines? Which can work 25, like entire day instead of 8 hours a day or 10 hours a day. Money transfers. Can we do what? Money transfers using chatbots. The loan applications. So we can design a chatbot which asks intelligent questions and find the right application. Like credit scoring, the financial advisors. A lot of things can be automated using this. Yeah. Next slide, please. Yeah. The fraud prevention, customer service management, account management, insurance claims, one of the major finance technology and financial planning. So a lot of things can be automated, and this can improve the efficiency, cut down the cost. At the same time, you can provide services to entire day instead of only 8 to 10 hours, so that you can retain your customers in a better manner. That is one of the major applications, because if you say that you work from 9 to 5, people might not accept. But if you say that you work 24 hours a day, people might accept much better. So that's, I see that's one of the major application. The second is revenue yielding. Yeah. Then you might ask, what is generative AI? Why we should know about it? So essentially what they do is, given a lot of training data, they can understand the training data and write stories for you, create videos, create audios, and create any content for you, given a right training data for it. Yeah, no, go back. Why it is called a generative? Because it can create something which is not exist. So given a training data, it can create something not exist. That is the reason we call it is a generative AI. Then you might ask, what is the difference between the previous discriminative AI and generative AI? In a discriminative AI, simple application is, if you given a set of images, you ask what is in the image. Is it a lion or is it a rabbit? But here you can ask a question like this. Can you draw a nice picture where rabbit and rat sitting together, lion and rabbit sitting together in a nice meadow? And it can generate image for you. That is the reason it's called generative AI. Yeah. Next slide, please. So essentially what it do is, it's simple. If you ask me mathematically, it's simple thing. Given a training data, it understands how this data is distributed over the multi-dimensional space. So it essentially study the probability distribution. Once you understand the probability distribution, it takes a sample out of it. It's the mathematics, basic idea behind this. Yeah. So it can create images, it can create audio, it can create text, very interesting. It can create videos also. So a lot of things can be created using generative AI. Yeah. Go ahead, please. Then you might ask, yeah, real math. So then you might ask, how this magic is happening? What are the set of algorithms behind it, mathematical algorithms behind it, which are doing this magic? In fact, these four are the most heavily used mathematical algorithms behind this generative AI. One is called diffusion models. We'll see what the diffusion models are. The next is variational autoencoders, very old algorithm, but still it do a lot of things in finance. And generative adversarial networks, very interesting because I did my postdoc in game theory, and it essentially follows the same approach. And transformers, ChatGPT, what you call right now is, which is essentially this. These are the four base common algorithms what we use for generative AI. Let us go through it. Yeah. Diffusion models, let us look at it. Yeah. So the first couple of years, we saw meteoric rise of text-to-image generation algorithms. So one of the most common is OpenAI's DLA, as well as Midjourney and Stable Diffusion. These are a set of algorithms which can generate image given a text for you. In fact, DLA2 kicked off with the current generation of text-to-image applications. It created a lot of interest in the society. In fact, it defined the idea that by giving a sentence, you can generate a very nice-looking picture. Look at this image. It looks like it is generated by machine. It's not by painted by someone else. In fact, the sentence someone asked is, an oil painting of a monkey in a spacesuit sitting on a moon. That's it. This is a sentence given to the machine, and machine generated this image, entire image. Look at how impressive this image is. So this is the technology right now, what happening using generative. Yes. Can you go? Much more interesting one. Look at the image. How much one can pay for this painting? How much one can pay for it? In fact, it is generated by the Midjourney algorithm by asking the question, a man raises his voice to the clouds in a flood. That's it. This is the sentence given, and it generated this image. Look at it. Now you can imagine this technology where we are going is. What machines can learn out of it. Yeah, please go ahead. Okay, then you might ask how this machine is doing is. Again, machine is doing, borrowed some idea from the physics. That's it. Idea is very simple. The original idea was inspired for the non-equilibrium thermodynamics. This idea borrowed from the thermodynamics. Essentially, that will do what to do is, the essential idea is to systematically, remember sentences, systematically, slowly destroy the structure in the data and move towards a noise data. So we have original data with us, and slowly, systematically destroy in sequential steps, destroy the structure in the data, reach a noise, and again try to reconstruct back. So when try to reconstruct back, it learns how to create things. That's it. Idea is a very simple thing. If you look at this image.
Moves together towards noise, and you try to deconstruct
back. So we have the original image. We have the original image. From the original image, we slowly destroy the structure, and we receive a noise. And from the noise, again, try to reconstruct back. So in the reconstruction, it learns how to get back the original distribution. That's it. Idea is. This is the basic idea behind the diffusion models. So, and it creating, in fact, you saw two magics. And that's it. A simple idea, but it is creating a lot of things in the image processing applications. Can you go ahead? Yeah, please go ahead. The second is the variational autoencoders. And this is a very simple idea, and a lot of applications in financial domain. So let us look at some applications in the financial domain where people are using this variational autoencoders. And again, they are not computationally intensive. If you go to diffusion models, we need GPUs, other things. In fact, variational autoencoders, we don't need complicated machinery at all. We can easily implement these things, and a lot of applications in the financial domain. Yeah. One is the anomaly detection. We can implement anomaly detection algorithms using the variational autoencoders. The fraud detection. These are, in fact, common applications. But if you move on to it, the portfolio optimization. In fact, you can implement portfolio optimization algorithms using the variational autoencoders. How they do is very simple. So the autoencoders can learn the underlying structure of the historical market data And from that, once you understand the historical market data, probability distribution of it, sample from it. Idea is a very simple thing. So in fact, it can be used for portfolio optimization and risk modeling. In fact, we can use this autoencoders for the risk modeling applications as well as option trading. In fact, people are doing extensive research on option trading using a variational autoencoders. These are the few applications of variational autoencoders. Let us see what it is actually. I said that we can do a lot of things in the finance, but what it is. Again, idea is very, very simple idea. Let us look at what is autoencoder is. It's essentially we have two neural networks, nothing more than it. We have two neural networks. One we call encoder, one we call decoder. Idea is a very simple thing. We give the original data here and pass on through a neural network, encoder network, and what you get is an intermediate representation. I'll call it latent space, what you call this. And again, we give this to the decoder network, and decoder network try to reconstruct back. That's it. We have original data, transfer to a encoded space, and try to reconstruct back so that the original data and the final data should be almost match. That's it. Autoencoders. Essentially, we have two simple neural networks. For example, let's look at, so input can be image, and we pass to the first network, what you get is this one, and try to reconstruct it. That is what we call autoencoders. Essentially, we have two simple neural networks. We put back to back. That's it. So we don't need very sophisticated computation. The normal good computer can do this one. Can you go ahead, please? Then we move on to this variational autoencoders, which I said that a lot of applications in the finance. The minor change compared to autoencoder and variational autoencoder is what we give the input here, and what is the intermediate representation is a probability distribution over the points in the, that's it. And again, once you have it, we take a sample from it and reconstruct it. Can you go ahead, please? Yeah, that's it. Let us look at it. The input is image. The intermediate representation is the probability distribution. From that, you take a sample and construct it. This is called what? Variational autoencoders. Look like very simple. But if you look at applications, the immense applications it has in the finance. But ideally, the implementation is very, very simple thing. But the applications can be really. That's the reason we, can you go ahead? So, can you go ahead, please? Yeah, essentially, once you generate, okay. Then you might ask how it generates the new data. How it generates the new data. So if this is the intermediate representation, from that we take several samples. And each sample is one possible image generated. So we given the original image, and we get the intermediate representation. And in this example, we taken two samples, and two samples given two images are slightly different. That's it. That is the how much time? Yeah. So let us come to this generation GANs. They're very interesting for me. Two motivations. They can generate the content, but I like, because I told earlier, I did my postdoc in game theory, which essentially how the rational agents interact. It's an entire thing based on how these rational agents interact. Yeah. So in generated adversarial network, essentially we have again two neural networks, but they don't cooperate, they compete. Idea is very simple thing. We have two networks. Instead of cooperation, previously they are cooperating networks, now they are competing networks. So we have two networks. One is a generator network, and one is a discriminator network. What we do is that we ask them to fight among each other. In the fight, they become much more strong, much more smart. That's it. Can you skip the slide? The next slide? Yeah. Let us look at pictorially how this works. Let us look at how this works. Very simple thing. Let me take 2 minutes about it, and let me explain this interesting idea. We have a generator network here. Generator network is try to create the content what you want. It can be image, it can be text, or it can be video, whatever it is. The generator try to create the content what you want. And this is the real data set, the training data set, what you have. So we have one real data set, training data set. And this is the content, this is a generator network, neural network, which creates new content. So I have two contents, the real content and generated content, and both we give to this neural network, the discriminator network. Now, what these two will do is they compete against each other. So this will try to create a content. So objective of this one to differentiate between the real content and generated content. And the objective of this is to pull it. Generate a content such that it can't discriminate it. That's it. We have two neural networks which compete against each other. The discriminator try to differentiate the real and generated, and generated try to create a content which discriminator can't differentiate. This idea, so they fight for maybe 1 day or maybe 2 days based on your computer, based on your GPU. And after the end of the 2 or 3 days, you get a nice content generation model with you. And can you go back? Can you go back? Yes. Look at these images. In fact, all are fake.
If you look closely, you will realize all are fake.
All are fake. Okay. In fact, but can you say they're fake? In fact, they look like very perfect images, look like images of real people, but they are not. In fact, all are fake images. All are fake images. That is the power of this algorithm. Can you go ahead? Yes. Now let's look at one extension of this GAN called a style transfer. So essentially, I can't paint like someone like Van Gogh. I can't be a painter. But at the same time, I want my painting should look like a Van Gogh's painting. Of course, I can do that now, right now. I can paint it, and I can give the machine and say that convert like a Van Gogh's. And machine can do that one now. So essentially, these are the original paintings, and I can translate to whichever type I want. The input is what you draw, and the output can be, it can be Van Gogh's painting, and it can fetch you millions or hundreds of millions. So that is so you can style transfer, what you call is. And in fact, it is very scary technology in 2024. So let me explain why it is scary. Yeah, go ahead. And go ahead. Let me explain this, why it is scary. How many know Kannada here? Yeah. And I think you know this guy, very famous guy. And in fact, he died before the movie release called, in fact, James movie. In fact, the movie is completed, but he died before dubbing is over. So what they did is actually his brother Rajkumar has given a voice over to it. Entire movie, and movie was released, but fans were not happy. The fans were not happy because they want to listen his voice, Punit Rajkumar voice, but his brother Shivaraj Kumar given a voice, but people were not happy. Then they approached us. Can you do something using the technology? Can we do something over the technology? In fact, we taken this project, and what we did is, same thing, the same technology, style transfer technology, we used it on the voice. Rather than images, we did on the voice. So what we taken is, we taken his movie clippings, the historical movie clippings of the Punit Rajkumar, and this movie clipping of, which is given by his brother. Then we applied the same algorithm, style transfer algorithm, on the voice rather than the image. And the movie was re-released again. And in fact, I went to the movie in first day, and I can see how the fans were crazy. So that's the reason I can say that this technology, because the rest is like theoretical, but this is what we did practically. This algorithm ran for 2 days. The conversion, entire algorithm taken us 2 days to translate from one voice to other voice. Yeah, please go ahead. This algorithm, let us not math. Yes, this is what right now is, which is actually creating a lot of flutter in the society, the transformers. Yes, please go ahead. Essentially, this, if you look at any sequence-related translations, previously we were talking about image-to-image translation, but when you're looking for something like a sequence-to-sequence translation, and in fact, this is the technology what can, in fact, it can do a lot of magics. So it achieved a great success in the natural language processing. So what it do actually? So given a sequence, so it's a set of words. Essentially, instead of understanding each word, it can understand the interrelation among the words. That is the basic idea is. Instead of understanding each word by word, we given a sentence, we have set a sequence of words, not set of words, a sequence of words, and it can understand how one word at a distance of 5 or 6 apart can change the meaning of other word. That's the basic idea is. Essentially, is a model neural network that learns context and the meaning by tracking relationship in the sequential data. So it learns the context as well as meaning by studying the relation across the words which can be far off, which can be far apart. It can be other sentence also. Need not be in the same sentence. So they use very recent technique called a self-attention mechanism. It's called essentially how one word affects the meaning of other word. How these words are interrelated. Essentially, we pass a sentence through the transformer. In the process of passing, moving from one layer to other layer, it learns how the words which are far off can change the meaning of the other word. So essentially, transformer models apply evolving set of mathematical techniques called attention and self-attention to detect a subtle ways how the distinct words will interact with each other. That's it. Yeah, please go ahead. That's it. Look at the sentence. Can you read it? Who wrote the sentence? ChatGPT. As I asked him the question, he said that he didn't know about it because it was trained before
Sobhan, mic.
Chandrayaan. So in fact, as of my best of my knowledge, up to date of September 21, Chandrayaan is not yet launched because it was trained. In fact, this sentence, the question I asked is, can you write small para about Chandrayaan 3? That's it. This is the sentence what I get from the ChatGPT. So that is the power of this the transformers. But computationally very intensive transformers are, but that is the power of the transformers. Technology is, yeah. That's it. In fact, when I was start learning about transformers, first thing is like, when you designing easy in a sensible state, are okay, because that is looking at it, very interconnected, highly interconnected set of neural networks, and millions and billions of edge weights. That's the reason it can learn a lot of interplay among the words. And it's very powerful technology, transformers are, but remember that computation is very, very intensive. So if you ask me, the fastest out of 4 models, what you talked about is, the fastest is variational autoencoders. Very simple thing. The GANs,
Maybe variational autoencoders right up to a super complex compute like the transformer-based models. And if you look at some of the headlines in story and you see companies like NVIDIA coming into prominence, for instance, that's because of the amount of power and amount of compute which is required for things like transformer-based models, right? The ChatGPT, for instance, the rumors are OpenAI and Microsoft have collaborated to use maybe 10,000 A100 chips, A100 cards. If you know what A100 card is, it's a fat card which sits on your server side. And even one is more than enough. But using 10,000 is a feat in itself, right? Now, of course, when we look at generative AI, the first thing that obviously comes to mind is you should possibly be automating routine tasks in the lowest hanging fruit, right? But I think what we as a society have to aim towards is things like creating of new jobs. I mean, what does it add to the overall story? What does a co-pilot add to the overall story? So the very concept and the very word of co-pilot is so powerful. You're not trying to replace the human in the loop. You're trying to enhance the human in the loop as much as possible. Right? And that's where enhanced productivity in all these applications come into picture. there are interesting set of questions that I'm going to leave it open to people here. So what about data? What about the actual content that is generated? Can you attribute it to somebody, or is it in play for legal reasons? Um, what happens to creative industries? I mean, how do they go a sea change? Do they get transformed? Do they adopt it very quickly? Or will they be left behind? Right? I mean, these are obviously important questions here. What about ethics, right? Meaning, are you playing on content that was used for training purpose, right? So if you look at each of these, the chat GPTs, the llamas of the world, they were trained on publicly scraped data. So which means that whenever something is generated, do you say that this data belongs to me because it has been trained on my data? Or, or is there a better way to formulate a vocabulary that allows us to address these concerns? How do you attribute it to anything in general? Right? If, let's say, wiki has been the source data for some generation, right? How do you attribute the generation of a piece of text to an original wiki content? What is the thread that links this source data to this particular generated content? What about privacy issues? Right? So when you're talking about things like ChatGPT, you obviously have to interact with the ChatGPT API, you have to upload your necessary stuff. But that does not work for large companies, meaning you would have confidential data, right? And people in large companies don't like hitting public servers to transfer that data so that just so that you can get that additional value. So what's the solution there, right? So these are interesting questions in play right now, and you'll see this area even grow further in the next few years. Now we're going to close it here and open the forum for
Yeah, one more.
questions.
Can you go back? Most scariest thing is, do you know who wrote the slides? Do you know who wrote last two slides? Three slides. Do you know who wrote it? Yes, of course. That much scary things can happen.
A few were created by ChatGPT. Take, yeah. You can give.
Hello. Yeah. So, Professor, one very interesting thing for me is, the episode of, the movie that you shared.
Yes.
Voice is also a biometric item for us.
Yes.
And as Jay had mentioned, it is very scary that, such things can be generated. Now, what is the responsibility of, how do you make it ethical and legally correct, valid to generate such things? That is one thing that I'm interested in. And the second thing is, how do you differentiate what is generated and what is not? Because something like GAN that you shared,
Yes.
it forces things to be similar.
Yes, correct.
So this is my question.
In fact, this is one of the major area of research where how we can differentiate generated thing with the real thing. In fact, when you went to the movie and the quality what you generated is enough for the movie, but at the same time, my machine can say, is it real or is it generated? But humans can't differentiate it. But still, still we are, whatever generated content is not exactly equal to 100%. Right now, we have, in fact, people are doing a lot of research on how to differentiate the real and the generated. And if you ask ethical context, that's the reason, in fact, I said that 2024 can be a very dangerous year because the elections are coming and you don't know who is giving the speech. And it can be very, very scary. 24 can be.
All right, we can have one more question.
I have a question. It's regarding the same movie, the audio generation for the actor.
Yeah.
What is the hardware that you've used to run the audio generation, and was it distributed or did it run on one GPU?
One GPU. That's the reason I took 2 days to translate. If he give me TCX, I can do in half a day.
So if you need to generate, if you need to run generative AI models, is there a way to run it in a distributed manner? I mean, do you have any existing technology or projects that allow you to run this in a distributed manner
In
to
fact,
speed up things
yeah,
beyond a single GPU?
yeah. In fact, in the transform models, the training can be might not be difficult to distribute, but generation can be distributed. The generation can be, because in the transformers, generation is a more time consuming thing because it is sequential data. The generation can be very time consuming. There, the better is to distribute across some machines. Training, still we are working how we can parallelize the training and slightly involved, but generation can be easily parallelized and which is time consuming.
Sir, I had one question. So we understand that these are very compute intensive and the models are very large in size. Do you see anything along the lines of generative AI on edge devices where we could have very small model files and very low compute where you could do it on device, because you said that enterprises wouldn't want data to go to other servers. You know, could something like that happen on an edge device?
Can I try and answer that?
Yes, please.
So this is always going to be possible. It's not about it being compute heavy or not. What are the kind of compromises you are willing to make? So if you look at all these models, they'll come with a t-shirt size, right? XXXL is what we are dealing with right now.
Right.
If you're dealing with something which you want to operate it or operate on an edge device, a small edge device for instance, you have to realize that you are going to pay a cost. That cost will come in terms of quality. What is that norm? What is the calibration that you have to do? That depends on you. If you think that quality is dropping substantially for you at a cost which allows you to basically go to market with a small device, maybe that is the play for you. But if you think that quality matters, maybe a ChatGPT like output matters, then you are in the play with the players like OpenAI, Facebook and so on, right? Meta and so on. That's a different ballgame, right? So there are sliders to quality versus t-shirt size for each of those models. We'll take
All
one
right.
last question.
Okay,
Yeah.
the last one, please.
We'll take the mic, please.
Yeah, thank you for the wonderful presentation. I have a question that how AI can be used in teaching. If precise to the management students, because I am from the Wellington Institute of Management, so I want to learn that how AI can be used in teaching.
How to teach her?
Yes,
Sobhan,
as
you
a
are the best
teacher.
person to answer.
And is it ethical to use it? That is also.
So,
No, I think
so you want to take away my job, I think.
No, actually, I was trying to get the answer, but I couldn't get it. So I thought you are here, so better to ask this question to you.
So, I am not using it till now, frankly.
So far, I am also not using, but is it ethical to use or how to use it if it's ethical?
I don't see any ethical issue. Essentially, but how to use, I don't know exactly, but I don't see any, if there is a way, I don't see any unethical way of using AI to teach students.
I'll try and answer that a very different way, right?
Sure.
And tell you in contemporary standards how it's
Yeah.
happening across the world. If you look at some of the universities in the US, how they are adopting it, they are using this, okay? But they're very wary about whether this is going to affect homework. Okay, they're not looking at the teacher's perspective, they're looking at the student's perspective, right? If your question is more from the teacher's perspective,
Yeah.
and your question is about ethics, I'm not sure whether that's the right question. Your question should be whether it's about accuracy, whether this leads to right information for you. Because this is generated data.
Yeah.
And whether that generated data is purely hallucination or whether it's sourcing it, we don't know, right? So that's why if you see one of the examples that was used early on, it was ChatGPT in combination with something like a Wolfram Alpha, which is an answering machine. An answering machine based on facts with the power and the generative power of ChatGPT. So you're mixing the best of both worlds to give as much factual information as possible, right? Of course, ethics is a different question. Meaning if you're trying to say whether that source does not belong to me, but I'm still teaching it, I think maybe then you are dabbling in ethics as a question. The other side of the story is how much of this do you leave to students completely, right? And what the students give to you as homework, how do you trust that at all? And this, so people think that this is a brand new problem. This has never been a brand new problem. So people who are in the world of AI, they will realize that at a certain point of time in the past, when coding contests used to be the thing, people used to submit code that used to be borrowed or stolen, right? So plagiarism checks used to be in play. Now this is plagiarism checks on steroids possibly, right? So I can answer it that way, I suppose, right?
Yeah.
Thanks for the question.
Thank you. Thank
All
you.
right, we regret to inform that time's up already.